Oh, hello. I was wondering today, what would be a great science experiment? Then it came to me. PCBs and animals. Then again, we are surrounded by nature right now. And then I saw an animal, like an iguana. So I was thinking, what actually happens when an animal swallows a PCB? So I was thinking, and not only me, my friend Nick was standing here actually, he just went inside to get some water. We were thinking about, what if we did an experiment to simulate what happens when animals actually swallow this? And what we're going to do to do that, or to simulate that, is that we're going to take one of these PCBs, well, 3 PCBs actually, and we're going to put them in hydrochloric acid. And then they're going to be on different, then we'll check on them on different times. So we'll go from like 9 hours to 24 hours to 34 hours. And we want to see how long it actually takes for an animal to actually degrade one of these. And that's what our experiment is. So, stay tuned, and I hope you guys find it interesting. So now let's go check out on our materials, and then we'll get started.
Hi, I'm Nick. I just got back from drinking hydrogen oxide. Now, my companion, Abel, he forgot a few details, such as our experiment is the degradation of PCBs over time, and our reason for doing this experiment. So you know how PCBs are like metal and sharp, and they're plastic. They can cut your tissue really easy, essentially. What we want to find out is how long the animal that congested it will be in pain for, right? We want to find out how long it'll take for their stomach to degrade and to destroy the PCB. Hypothesis is that PCBs, after around 24 hours, will start degrading. Then afterwards, it'll slowly and linearly degrade over time. Maybe, I'm guessing, it'll take about a week or so to degrade, if it does.
Alright guys, so just one more thing we have to look at before we actually look at our materials. That is our variables. Sadly, Nick forgot to mention them. But, anyway, so let's see. So there's 3 different types of variables: independent, the dependent, and the control. So our independent variable is the amount of time the PCBs are staying in the hydrochloric acid. So there's the 8 hours, then 24 hours, and then 32 hours. And then our dependent variable is the weight of the PCBs. Because after we leave it in there for a certain amount of times, the hydrochloric acid may degrade the PCBs for more time. So we have the controls. We have multiple controls actually, so let's go through them. So we have the beaker we are using, the molar of the hydrochloric acid, the amount of hydrochloric acid, and of course the PCBs. So guys, let's get started and look at our materials.
These are identical PCBs. We have 3 of them, just to make sure that no trials have any anomalies, right? What we're planning on doing is we're planning on taking these and putting them in these 250 milliliter beakers, right? So what we want to do is we want to take this hydrochloric acid and then put it in these beakers. We'll leave each one for a different amount of time inside the beaker. So one of them will be left for 9 hours with the hydrochloric acid in it. First we're gonna take the weight. We're gonna measure that, right? And then after we take the weight, we're gonna measure the weight after the 9 hours to see how much of the mass has degraded, right? Then another one will be 24 hours, and then another one will be 33 hours, just to see if there's any exponential, if it degrades exponentially, or if it degrades in a linear pattern. Alright, so we're going to put 150 or 200 milliliters, right? Yeah. 200 milliliters of hydrochloric acid into the beaker. Alright. So what we're going to do is we're going to leave this in the hydrochloric acid for about 8 hours, right? And then after 8 hours, we're going to take one out, the mass of each one of these, right? We're going to find the mean mass of all of these together. And then now we're going to put them into the hydrochloric acid.
So while he's doing that, I guess I'll explain what we're actually going to be doing. So what we're going to be doing is, there's 3 PCBs, and for each one we're going to be pulling them out at different times. So for the first one, this one we're going to be going out for after 8 hours. This one for 24 hours, and then this one for 32 hours. And after that, we're going to take the average. Then we're going to weigh them again, and then take the average. Then take the mean of that, and from there we'll see how much mass these PCBs have lost through the hydrochloric acid. Alright, so this little update, we moved the PCBs and hydrochloric acid into this cabinet right here just for safety reasons. So now let's take one PCB out.
So, as you can see, we wanted maximum safety, so we put a danger sign on. Alright. So what we're going to do as procedure is hydrochloric acid can easily be diluted if you are to keep it in water. We forgot our latex gloves. So we're going to redo it without... Alright. So what we're going to do is we're going to use tweezers to carefully put it under the sink, right? The sink is the high pressure sink.
Just let it run first.
So what we're going to do is we're going to put it into the sink, right? Let the hydrochloric acid dilute, just to make sure that we're not going to irritate our skin, because hydrochloric acid is highly, acidic, so it'll irritate you pretty easily, right? And, alright, so now that we've what we're going to do is we're going to measure the weight of it. Okay, so it's 11.8 grams. So that's the 8-hour PCB. We're going to leave these two. One of them we're going to leave until tomorrow. The other one we're going to leave until tomorrow night.
Alright guys, so now we're going to take out a second PCB because it's all 750 now, so let's get that out. Alright, and now, well, Nick is going to actually wash it and then weigh it. There you go.
Alright, so just like we did before, we're going to dilute one of the PCBs, right? Just so that hydrochloric acid doesn't literally get everywhere. And then we're going to measure the weight of the PCB. Feels so bad watering down its neck. It hurts me on the inside. Alright, so now that that hydrochloric acid seems to be diluted, we need to zero it actually.
Yeah, 12 grams. Alright, and so now we're going to put this one back, and then we're going to reopen it at 350. Alright, make it over here. Now we're going to check out the third PCB. Alright, and so yeah, let's open up the cabinet and get it. So right now we're going to do exactly what we did last time. I'm going to give it over to Nick, and he's going to clean the PCB, and we're going to weigh it.
Basically the exact same procedure. What we're going to want to do is we're going to want to use tweezers and make sure to wear gloves just for extra caution, right? Put the sink on low. Don't forget, this is hydrochloric acid. You want to dilute it. So take the water, give it a nice healthy bath in that water, right, on both sides. Make sure of it. Get this whole thing basically soaked. Make sure it's not plugged into anything electrical. Alright? That's number one tip. Okay, water electricity, not at all. Alright, now that that's done, what we're going to do is we're going to put on the scale. And it measures 12.7 grams. And it might be a bit heavier due to the few droplets of water, but we can negate the extra weight on that. And that's it. That's the third PCB that has been there for 32 hours.
Alright guys, so now we'll move on to the next step where we start making our graphs and we actually start looking at our results. Alright, and so... Little quick analysis of our data. So when we started off, right, the first PCB had a mass of 11.7 grams, the second one 12 grams, and the third one 12.4 grams. Now, after 8 hours, when we took the first one out, that was at 11.8 grams, the second one was at 12 grams still, and the third one, after 32 hours, was at 12.8 grams. So we can see that the first one increased by 0.1 of a gram, and the last one increased by 0.4 grams. So this could be due, the increase could be due to the water that was still on the PCB when we weighed it, and if there was a decrease in weight, that could also be due to the exposure of the copper on the PCBs.
One of the limitations that we had was most likely that the hydrochloric acid was dead. It could have been old hydrochloric acid. We forgot to check that. And as I was disposing of it, right, the whole process of disposing it is you take a lot of water, you put a pound of baking soda in it, and you slowly pour the hydrochloric acid in, not the other way around. You shouldn't pour water into hydrochloric acid or else it'll have a violent reaction. Now, what that was supposed to do by slowly pouring the hydrochloric acid in is it was supposed to start to fizz up, right? Which means that it's starting to neutralize, and you should add more and more baking soda until the fizzing stopped. But there was absolutely no fizzing throughout that whole thing, so it was most likely dead hydrochloric acid. And also, time, the different things that we had to do throughout the week, made it a bit more difficult to have the experiment exact when it comes to time, and also the different time spans that we could have done it. We could have done it for a longer amount of time if we had a longer amount of time.
Alright, and now the research, the application of this research, I believe that this can be used to sort of see what actually happens with animals when they swallow it, and this can be used to further maybe stop certain types of PCBs, the making of it, so that way they're not ingested by animals.
And the way we can further this research is probably finding out the chemical composition of most of the plastics in PCBs, taking the average. So, like for instance, this group of PCBs has this kind of plastic, and this group has this kind. Whichever group has the whichever group is bigger, we're gonna test it on that, as other PCBs are more likely to use that kind of plastic, right? And we're gonna put that into some non-dead or live hydrochloric acid, and that's the way we can further it. We could also probably try putting in different chips as well.
Alright guys, so this is basically our experiment, and we just want to give a huge shout out to the YouTuber that let us post this on his channel. His name is Rabble Racing. I want you guys to all go and subscribe to his channel. It's really nice,
Like
man.
and subscribe, comment first, and we're gonna not do an Amazon gift card giveaway.
If you guys have any comments about this experiment, if you want us to improve something, or just say anything, just put it down in the comments below and hit that subscribe button. And we'll see you next time if we do an experiment.
Don't forget to hit that subscribe button.
Yeah, we'll see you next time if we do an experiment.
And the like button.